7.
Ooh,
8.
close.
9. 10.
Okay. That was
9.
booyah.
10. 10.
Oh, that was too flip.
7.
Oh.
9. 10.
Now we have to complete this one. Booyah!
Howdy everybody, and welcome back. Today I'm going to walk you through the light speed challenge and how we can put that together. In our first build, the drum challenge, we designed around the idea of a timed button press. And then in our second build, the traffic light sequence, we leaned heavily into loop behavior, cycling through a sequence of LEDs. Now this build puts those two ideas together. We have a loop of cycling LEDs, and we have the idea once again of a timed button press. But here's the twist. Every time the player gets it right, the loop gets faster, and they have to keep going all the way up to round 10 in order to win the game. So let's get this party on the road, shall we? So here's what we're gonna need for this build. We're gonna need, of course, the COGS digital master. In my case, I'm using 2 Ethernet cables and 2 RJ45 breakouts. I cut out 7 holes onto a box and I wired up all my LEDs. Here I have a button that doubles as an LED, so it can turn on just like all these other LEDs. Right up top, I have my 2 RJ45 breakouts coming out of the top of the box. Now let's jump into COGS and I'll show you what I have so far. We won't spend any time on setting up the digital master. I'm pretty sure you should be comfortable with that by now. But here are my channels. I have my 7 digital output channels, which are LEDs, and a button, which is a digital input channel. Now let's jump into the build. Now before we touch any behaviors, we need to set up a variable. So we go into the variables tab and we set up our numerical variable and we call it speed. In this case, this variable speed will control the delay between each LED. A shorter variable, or a shorter speed, will mean the sequence runs faster. So we make sure to allow decimals here. And let's set our minimum. I know I don't want it to go any faster than 0.05 seconds. And I'll set my delay to 0.55. Now, depending on how hard or how easy you want to make it, you can experiment a little bit, but I'll use these values for now. So now let's head into the behaviors tab and build in our first behaviors. So I'll get into a new scene and choose behaviors. Now I want to choose a started by action behavior. A started by action behavior is essentially like a function or a block of logic that doesn't run but just waits. We can call upon this block of logic from within another behavior. This gives us precise control over when certain things happen within our show. So let's go ahead and set up our cycle behavior. And I'll go in and set up a loop which cycles through my lights. Depending on the orientation that you choose, your loop is going to look different. If you have a ring orientation, you might want to just go right around with the speed variable as the delay. In my case, I went with a line orientation, so I want to go up and then right back down. So I'll program it quickly and then I'll run you through what I have. Now let me walk you through how I set up my loop cycle. So for starters, I want to make sure that all my LEDs are turned to the off position, after which I then begin my loop cycle. I want to go up the tower with all LEDs turning on. Then when I get to the top of the tower, I want to turn off the 6 LEDs at the bottom and now start coming down. Now on the up cycle, I want to set my variables to a fixed number. I chose 0.1, but you could set them up as the speed variable. On the way down, I have set up my delay as the speed variable, not a fixed value. So additionally, we need a behavior that keeps track of whether the button presses are correct. So this behavior, we can use a states match. let's call this button press. And we want to check for when button 1 is pressed. We want to then check for 2 conditions. Did the player press while the LED 1 is on or while LED 1 is off? So we can use an if then otherwise action. So we choose if then otherwise. And we want to go ahead and first stop the loop cycle. So we can use a stop behavior. Since we have a started by action, which is our loop cycle, we can stop the loop, which freezes it, and go ahead and check if LED 1 is on. Then go ahead and first update our speed variable. So we can find variable here. And we want to click this down arrow right here and subtract 0.05. I experimented with a few figures. I find that 0.05 works best for what I need. So after I reduce the variable to make the next round quicker, I will actually play the correct press audio. Of course, I've imported all my media files. You can also download them. And I want a little bit of a delay to give the player a little bit of a breather. So I will add a delay of 0.2 seconds. And then another delay of, which is the speed variable. And finally, you want to start the behavior again. Since we stopped it, we want to resume it in the event that the player has hit the button at the right time. And on the other hand, we need to handle what happens if the player presses this button outside of our window. So we want to first play the loser behavior, the loser audio, pardon me. So play audio. I have an audio clip titled loser. And I want to play it until it's done. After which I want to reset my variable in preparation for the next round. If we don't do this, then it's gonna start fairly quickly. So let's go ahead and update our variable speed. And we want to reset it to default. After which we want to go ahead and end or finish the scene. So far we've handled our loop behavior as well as our button press with the 2 conditions. But we need to handle what actually happens to start the game. I would like to start the game when the scene actually starts. So I set up a behavior, which is a when scene started. I want to call this start game. For starters, I want to play a little bit of a countdown, like a 3, 2, 1, and then the game actually starts. So I'll set up an audio. So I will go ahead and set up an audio, which is a countdown. And I want it to play until it finishes. After which I want to start the game background audio. I've chosen sort of like a drum beat kind of sound. Of course, you can choose something that fits the mood you're going for. It's called the Indian Happy Action Drums. And then I want to call upon the cycle behavior to begin. So remember, we can call upon this because it's the started by action. So I'll go ahead and choose start behavior, and I'll click on start the cycle. So what this does is when the scene starts, all these behaviors, all these actions will be rolled out, ultimately leading to the start of the game. Now we're in the home stretch of our build. And you might recall that the goal of the game is to play it until about level 10, at which point it will be a little bit too fast for anybody to win, really. So we might want to keep track of the round that each player is playing. And when the player actually succeeds or finishes round 10, we actually declare them the winner and roll out the winner behavior. So let's go back into our show and access our variables tab here. You could also have local variables within the scene, but I decided to put them as show variables. So I will add a new variable, which is also a numerical variable, and I'll call this round. Okay, for the round 1, round 2. And this is also a numerical variable. This time I don't need decimals, so I won't tick this box. And the maximum is 10, minimum, let's call it 1. Default value, let's set it to 1. Great. Now that we have the round variable, we go back into our scene. And let's add a new behavior. Let's also make this a started by action behavior. Let's call this level. Now, you might remember we can use an if then otherwise action to check for different conditions. But in this case, we actually have many conditions. So we actually can nest these if then otherwise conditions. So if we're in round 1, go ahead and say round 1. Otherwise, we add another if then otherwise check in there. So I'll program this pretty quickly and I'll walk you through what I have. So I've built out all the conditions or the checks that we need to do to check which round it is. So let me make it a little bit smaller. So we check if it's round 1, go ahead and play round 1 audio. And we keep going, we check if it's round 2 all the way up to round 10. So we check if it's round 10. If it is indeed round 10, we play the round 10 audio. And after, if somebody actually completes round 10, then we want to trigger the win behavior. So they've actually finished the game. So the otherwise condition would do exactly that. So let's go ahead and program what happens if they succeed. So first of all, we want to stop the loop cycle. So let's go ahead and stop behavior. Remember, this is a started by action, so we can stop it. After that, we want to stop all audio. Remember, we have the background audio that's playing in the background. So let's go ahead and stop that. And after that, we want to play the winner audio to show the person that they are the winner. And we want to go ahead and play it until it's finished. After which, we might want to add a little delay, maybe of 1 second. Why not? And then go ahead and finish the scene. All right, so now you might think we're done, but we have to go into the button press behavior. And when the player hits the button at the right time, we want to update our round variable. We haven't done that. And also we want to reset our round variable. So here we go. So we go into our press behavior and we want to also add and we want to update our round variable and add 1 to it. All right, so with each round it adds 1 as we keep going. So if we go into the otherwise condition and we want to also update our round variable and set it back to default. We can set it to 1 or just to default value. Okay, so it's looking pretty good. Do we need to do anything if the player actually wins the game? Yeah, we need to do that as well. So we go into the level, we go into the last condition, and we want to actually update our round variable back to default such that if somebody wins the game, we reset it. Okay, great. All right, pretty good. So we've made it to the end. Let's recap everything we did in this build. So we set up 7 LED output channels and 1 button input channel. We created 2 variables. The speed variable controls the timing of the loop, and the round variable checks how far the player has gotten in the game. We went on to build in some behaviors. Our first behavior starts the game when the show starts. We went on to set up a started by action behavior, which is a loop that loops through our LED sequence with the help of the speed variable. We then went on to set up the button press behavior that checks whether the player has pressed the button at the right moment, rewarding each correct button press by speeding up the loop. Our final behavior was the level behavior. It relies on a number of nested if then otherwise actions to keep track of the player's round and announce the level after the successful completion of each round. The thing to take away from this build is actually the power of variables. Now, because every delay inside our cycle behavior points towards the speed variable, one subtraction of 0.05 seconds automatically makes every step in the loop faster. You don't have to go in and update 12 different delays. You update once, and the changes take hold across the entire build. Now, this is the true power of variables within COGS. Now, if you're feeling extra confident, see if you can start the Lightspeed challenge like this. Now you can skip ahead to the unit on how we can use scenes as game states to help you figure out how you might achieve this. But that's it for this build. My name is Joel, and until we meet again, build on.